Hey everyone, welcome back. Class number 3 in our Algebra 1 course. We're going to be breaking down properties of equality today. So let's dive straight into it. Goals for today, we're going to talk about what properties of equality are and then how we use them when we are solving single-step or two-step equations. We'll talk about these identity values, which we've touched on in class a little bit, but I want to put something formal on it. And then we're going to look at a new way of solving. And this is more of a way to display your answer and your thoughts using a statement and reason table. And I'll explain more about that in a few minutes. Essential questions for today. What are the 4 properties of equality that we're going to look at in class? So obviously in past tense that we have looked at already. And then what's an identity value? And then why are statement and reason tables useful tools to use? All right, a property of equality. You can read the definition on the screen, but essentially a property of equality is something that we know to be true. So a property is something that's been shown to be true that preserves equality. So when we've got an equation, we're going to use these properties of equality to allow us to manipulate and change the equation to find the answer that we are looking for. And we know that doing these things is true because they have been shown to be true properties. We don't have to go and prove it, thankfully. We get to just assume that they are true. All right, here are the 4 properties of equality. I'm going to go through each of them individually. You know what all of these are already. It's just you may not have ever called it by this name. So addition property of equality, if we have an equation, we can add the same value to both sides of the equation without messing it up, without unbalancing the equation. So you can see the example over here, A equals B. Well, if I add a C value to one side and add a C value to the other, then the equation is still balanced. Whatever A and B are, they're equal to each other. If I add another value that's the same on both sides, then the equation is still equal. So we've been doing that for years, I'm sure, solving equations, but I don't know if you ever knew that that was called the addition property of equality, when I add the same thing to both sides of an equation. Subtraction property works the exact same way, except if I take away the same value from both sides of an equation, then the equation will still remain balanced and equal. It will still be a true statement, so I can subtract a C value from A and B if they are equal to start with. Multiplication property, this is one that catches some people out. If you have an equation, you can multiply both sides of the equation by the same value and it will keep the equation balanced. So imagine like if I had a value of weight on one side of a scale and it was equal to a weight on the other side and I doubled both sides, well the scale would still be balanced, wouldn't it? What catches people out here is that you have to do it to the whole side of the equation. So say I have something like 3x plus 2 equals 1a, and I say this is an equal statement. If I multiply this side by 2, I have to do the whole side of the equation, and then same thing on the other side. I have to multiply both sides by 2, and then it would still remain an equal value. So I can't just do like 2 times 3x. I have to do 2 times the entire thing, and then 2 times the entire thing on the other side. And then division property, exact same thing. You can divide both sides of an equation by the same value, it will remain equal. So like if you cut both values on either side of an equation in half, then you would still have the same amount equivalent to one another on both sides. So just kind of stepping into another definition. And remember, you can always pause the video if you need to write things down or add notes for yourself. I just assume on the video that you can pause, which is why I'm not leaving time for writing things down. You just pause as you need to. An identity value, we've talked about this in class a little bit. This is a value that will not change another value if it is added, subtracted, multiplied, or divided. So thinking about that, what is something that you can multiply any number by? So if I had number A times any number and the answer would still be A. Or A divided by some number and the answer was still A. So of course that number must be 1. So you can multiply anything by 1 or divide anything by 1 and it does not change the value of the original item. So that is what we call an identity number for multiplication and division. For addition and subtraction, think of it this way, A plus something equals A, or A minus something still equals A. Well, that something must be 0. So you can add or subtract 0 from any number and you just end up with the original number again. So 0 is an identity number for addition and subtraction. Now, why do we care about what an identity number is? When we are using the properties of equality, we are going to try and produce identity numbers as we try and isolate a variable. So the word isolate means to put on its own. If you think of someone who's in isolation, they are on their own, they're not in contact with anyone else. We are isolating a variable. So like if I have something like 3x plus 5, my goal is to get that to look like x equals blank. So you're trying to get rid of the 3 and the 5. We're going to use our properties of equality and inverse, identity values to do that. So the way we want to use identities is to think of the inverse property. So what can you multiply, divide, add, or subtract a value by so that you end up with an identity number? So like for multiplication division, if I had 2 and I divide it by itself, I get 1. Or if I had the number 3 and I multiply it by a third, I end up with 1. So remember, 1 is my identity value for multiplication division. So that means that you can divide a number by itself, or you can multiply by a fraction, which is an inverse of it. So like 3, for example, is 3 over 1. If you multiply that by the flipped fraction, you end up with an identity value. If your fraction was 2/3 and you multiply by 3 over 2, you end up with the identity value. So you're flipping the fraction or you're dividing by the same number. For addition and subtraction, what would you have to add or subtract to a number to end up with 0? It would be itself. So if I have 3 minus 3, I get 0. So 3 and negative 3 are identity inverses of each other. So they're inverses of each other. 4 plus negative 4. So negative 4 is technically the inverse of positive 4, or we could say subtract 4. Either one works for me. All right, stringing it all together. Here's what we're trying to do. The problem we're given is g minus 7 equals 11. And that's what's given to us. So that's why it's called a given statement. If I want to get g on its own, then minus 7 needs to go. And what we're going to do is we're going to say, if I add 7 to both sides using the addition property of equality, I'm allowed to do that because of the addition property of equality, then positive 7 and negative 7 will form an identity number of 0. So effectively they will cancel out and I'll be left with just g. And then whatever I do left, I have to do the right because of that addition property. So I add 7 to both sides. I can combine 7 and 11 to get 18, and then minus 7 plus 7, they equal 0, and g plus 0 is just g, so they effectively cancel out, and that allows me to isolate the g variable. So I'm trying to use my vocabulary as much as possible to get you used to it. This is what we call a statement and reason table. So the statement goes on the left, or work and property used. I don't mind which way you write it. I'm going to typically write statement reason, and this is something that we really use in geometry a lot, but why not introduce it to you now so that when geometry comes around, you're not like totally confused by it. So on the left hand side goes your work, on the right hand side goes a verbal reasoning as to why you did what you did, and you're trying to think of properties and
Good afternoon. Anyone that...
Sorry about that. Okay, so we want to use those reasons to support our work. And in geometry, what you're doing is you're creating a proof, so something that cannot be thrown back at you and say, like, that's not true. You haven't shown that. You are showing without any reason or without any doubt that this must be the right answer. So this is what we're going to try and do in algebra as well. So it's a great build up to geometry. So for the next few problems we do, we're not going to do this for all of Algebra 1, don't worry, but we are going to get in this habit of thinking this way as we solve problems. So things that you'll be putting on the right-hand side are the given statement. That's what you always start with, so the problem you start with. and then you'll start thinking about, okay, what properties of equality am I using? And then you can always use the word simplify for like if you're combining like terms. All right, so let's take a look at this one. 15 equals 12 plus k. I want to get k on its own. The 12 is on the same side of the equation as k, so the 12 needs to go. It's being added to k, so I know if I subtract 12 from both sides using the subtraction property of equality, I will be able to get k on its own. So I subtract 12 from both sides. 15 minus 12, I simplify that to get 3. 12 plus k minus 12, the 12s cancel, I'm left with just k, and the answer 3. So make sure you're taking these examples down. You've seen some working examples of how this is going to look in your notes and in your answers. All right, looking at this one, 6 times a equals 48. That is my given statement. I want to get a on its own. I need to get rid of 6. 6 is being multiplied by a. So if I want to get a on its own, I need to remove the 6, and the way to do that, to undo multiplication, is to divide by 6 on both sides. Because we saw if I take 6 divided by 6, I get the identity value of 1, and 1 times a is just a. So I need to divide both sides by 6 using the division property of equality. So I put that into my next line of my problem solving. And then 6 divided by 6 cancels out. So 6 divided by 6, I'm left with 1, and then times a, which is just a, and then 48 divided by 6, I'm left with 8. So my final answer, a is equal to 8. All right, our multiplication property. We've got d over 5 equals 2, and a fraction, remember, the denominator is the same as saying d divided by 5. So d over 5 is the same as saying d divided by 5, or 1/5 times d. I want to get rid of the 5 because I want d on its own. If I want that to cancel out to be an identity value, I need to multiply by 5 on both sides. So using the multiplication property of equality. So if I multiply by 5 on both sides, so really what's happening is like your fraction pushes together, so you would end up with 5 times d over 5, and then you're saying, oh, I'm multiplying by 5 and I'm dividing by 5. Those are inverses of each other.
Mr. Spurrier, can you?
Apologies again, recording a video at the end of the day. So 5 divided by 5, that is going to cancel to be 1, so I would end up with 1 times d. 1 is an identity value, so I'm left with just d, and then 10 on the other side. So that is how I'm solving this down. Now you may be looking at this like, wow, this is way too much work for something that I can do in my head, and I don't doubt that you can. But when the problems get harder, this is when you want to have this kind of thought process going through it, and this is the routine that you have already built for yourself. And then especially when we go into geometry, you're already like very competent with what a statement and reason table is as a method of solving. All right, I have 2 more examples for you that I want to do where I'm going to go through start to finish with you. Definitely take them down. If you want to try them on your own first, go for it. Just pause the video and then look at my explanation. But I'm going to run through each of these with you right now. All right, so in the first one, we've got minus 6 equals b over 18 plus 12. So the first thing you do is just rewrite your question, especially like if you're copying it from somewhere else. If you're not, you don't necessarily have to. In geometry, you will have to. So your first line is always your given information. All right, so then I know my 6's and my b's look very similar. Apologies for that. I need to get b on its own. So I want a statement of b equals at the end. So this is what it should look like, or equal sign can be on either side, it doesn't matter. But I need to get rid of the 12 and the 18. We've talked about solving single variable equations that we use reverse PEMDAS. So any addition subtraction is going to go first. So even though the 18 needs to go, I want to get rid of the 12 first. You can remove 18 first. It just would require you multiplying both sides of the equation by 18. So that would mean putting the whole right side in parentheses, multiplying by 18, and then the whole left side. So you'd have like a 12 times 18 in there too. I don't think we want to do that. Let's stick with reverse PEMDAS. So the 12 has to go first. We're adding it. I want it to be 0 because I want it to be an identity value, which means I need to subtract 12 from both sides. So I'm going to have minus 6 minus 12 equals b over 18 plus 12 minus 12. Sorry, I'm writing very small to fit it. And then what happens is the plus 12 and minus 12, well, that equals 0. So they effectively cancel out of this, and I'm left with b over 18. Minus 6 minus 12 is negative 18. All right, so then I still need to add my property of equality. I subtracted from both sides, so that is the subtraction property of equality. If you're going to abbreviate subtraction, make sure you put in the SUB and the T as well. We're not looking at it right now, but there is also a thing called the substitution property of equality. So SUB could be subtraction or substitution. So you want to make sure you're adding in an extra letter just to clarify which one you're talking about. All right, so b over 18, we're dividing by 18. I want that to be a 1, so I want b on its own. That means I need to multiply by 18 on both sides. So I'm going to have 18 times minus 18 equals b over 18 times 18. So then my 18 divided by 18, so it becomes 18b over 18. They cancel to be 1, which just leaves me with b. And then 18 times 18 is negative 324. All right, so then let's see, we've got up here, this was simplify. So that was when we just like crossed out everything, combined like terms. You can say combined like terms, you can say simplify, but that's effectively what we did when we crossed out and we said minus 6 minus 12 is negative 18. Then down here, we multiply by 18 on both sides. So this is the multiplication property of equality. And then finally, we also simplified again. So we crossed and combined like terms. I just realized I wrote simply up here. Simplify. There. So it's more work. I understand that. It's more work than you would normally need to do for an equation like this. I will not make you do this for every single equation that we do in Algebra 1, but I do want you to practice it for right now. So on the right-hand side, I took away the rows just because I wasn't sure how many rows I was going to need for this. Okay, so we got our given statement. And then I usually just draw a horizontal line under each one so that I know which ones are separate. We've got A's on both sides. We've got an A on the left and A on the right. We've got numbers on the left and numbers on the right. 15A is bigger than 1A, so I'm going to bring the 1A over. Now, when I say bring it over, that means I need to subtract it or divide it out of one side of the equation, and it therefore will end up on the other side. So in this case, if I subtract A from both sides, so I do a minus A and a minus A, I'm using the subtraction property of equality. To solve this down. So you notice now I'm starting to shorthand a little bit more, which is totally fine. So A minus A, they will cancel down to be 0, because that's an identity value for addition and subtraction. And then 15A minus A is 14A. So minus 129 equals 14A minus 3. And this line was just a simplify. Now we want to get A on its own. We got to add 3 to both sides to get rid of that minus 3. So I'm going to add 3. So this time we have an addition property. All right, and that's going to leave us with 3's will cancel down to be 0. So we'll have negative 126 is equal to 14a. I'm going to run out of space. And this one was simplify again. All right, so to get a in its own, we would have to divide by 14 on both sides. So 14 divided by 14 is 1. That will leave me with an a. And then negative 126 divided by 14 is 9. And negative 9 in this case. So negative 9 equals a. So I've got a division property. And then just to kind of squeeze it in, the last line would be simplify. So you'll notice that like in your notebooks and stuff like that, these will take up a lot of space too. So yeah, they take time and they take space. Once again, we are just training our minds on how to think this way. And eventually you will start doing this in your head, but as long as you're doing this in your head and not something else, you know, that's what we're looking for. If you're doing something else, then we're not quite there yet. All right, your turn. Pause the video and then come back and see how to solve it. And again, we're doing this with statement reason tables. So I know you can solve this without one. I want you to solve it with one now. All right, so for the first one, 10x plus 11 equals 121. I need to subtract 11 from both sides to try and get closer to having 10x. So I'm trying to isolate the x. Reverse PEMDAS tells me addition subtraction should go first. So that would be 10x equals 121 minus 11 is 110. And so this one was given subtraction property and then simplify. So notice I am getting shorter and shorter hand as I go, which is totally fine. I want to get x on its own. It's multiplied by 10. So if I divide by 10 on both sides, so that would be the division property of equality, I get x is equal to 11. So very simple. You can always check your answer first and see like, okay, let me solve it my way first. I know what the answer is, and then go through the properties and see can you match them up. So these two go together, these two go together, these two, and these two. I should be doing a table, I'm sorry. Let's do that table. So I just put S and R, statement and reason, or work and reason, whichever one. So 3a minus 7 equals 1 minus 2a all over 3. So a lot of things that has to happen here. We need to combine like terms. Probably the first step here is to get rid of the fraction because it's hard to combine like terms when one's on a fraction, one is not. So this is all being divided by 3, which means that to undo that, or to get an identity value back, we want to multiply by 3 on both sides. So this is one of those ones that catches a lot of people out. It's 3 times the entire left side, so that would be 3a minus 7 is equal to 3 times 1 minus 2a all over 3, and I know I'm squeezing that in there. So then 3 times 3a is 9a. This is a distributive property. 3 times minus 7 is minus 21. And then on the other side, you don't have to distribute because everything is divided by 3 and multiplied by 3. There's a reason we put it there, and that was so it would cancel. So we get 1 minus 2a. So over here, we've got the multiplication property of equality. And then we technically we use the distributed property. I don't really need that right now. I'm not focused on that in this lesson. We just simplified. Moving next, we need to bring the numbers together, so combine like terms. 9a is greater than negative 2a, so I am going to add 2a to both sides. Now, if you're feeling confident in what you're doing, you can say, I'm going to do these both at the same time. So I want to move the negative 21 over, so I'm going to add 21 to both sides. So 2a and minus 2a will equal 0, so they cancel. Negative 21 and positive 21 equals 0, so they will cancel. It leaves me with 11a equals 22. So what we did there was the addition property of equality. And then 11a equals 22. We want to divide by 11 on both sides. So that 11 divided by 11 is 1. We get left with a. 22 divided by 11 is 2. And this was the division property of equality. And then we also simplified. Hopefully you got both of those answers, like you got the 11, you got the 2. That's great, but it's not quite fully what I'm looking for here. I'm looking for that full table. So just be expecting that if I ask you to solve something using a statement reason table and you just give me the answer, you are missing the majority of what I'm actually looking for in that question. It's great that you found the answer, but it's not what I'm looking for. I'm looking for you to show a thought process and a system that relies on things like properties of equality. All right, so the next bit of practice we're going to do in class is on page 8 of your textbooks. You'll be using questions 3 through 10. You can access your textbook online if you would like. Go to your FCPS bookmarks and then the My HRW. You should be able to find our textbook there. So you're looking for the Algebra 1 textbook. We're at the very beginning, so the Unit 1, Module 1, and you go through the options until you find the right page, and then you can copy them into your notebook. I recommend using the textbook. It's in class. You should have a textbook assigned to you, or it's still sitting on the shelf waiting for you to pick it up. So you can just grab a copy, use it, and then put it back if I haven't assigned them yet. All right, that brings us to the end of our class. So our essential questions for today: what are the 4 properties of equality? It is the addition property, subtraction property, multiplication property, and division property. And they basically say if you do any of those to both sides of an equation, the equation stays balanced and stays equal, so it preserves equality. An identity value is anything that you can add or subtract to a number and it does not change its value, so that'll be 0, or anything you can multiply or divide a number by and not change its value, and that would be 1. Statement reason tables, it's a method of solving an equation where we are showing our reasoning for each step that we do in solving. It's a great brain exercise. It helps train you to think in terms of steps as opposed to skipping to the end. It reduces error and it makes sure that you understand what you are doing, and it shows it too. So as a teacher, it's very valuable to me as well. And then for tonight or for the rest of class, you are pulling out your textbook and working on those questions, showing your answers with statement reason tables. If I did not say that before, let me say that now. Make sure you use statement reason tables in your answer. I'll talk to you next class.